Welcome everyone to ResNet 2021 conference session, 2020 data trends in HERS ratings, what drives low scores, how that has changed since 2019, and what's up or down with ACCA 310. We've got myself speaking, Cy Kilborn from Ekotrope, Vice President of Engineering here. Also with me, we have Jacob Kamen.
Hey, Cy, thanks for having me. And I am Jacob Kamen, an account manager here at Ekotrope, and I manage a lot of the users' accounts who use our HERS rating product.
Wonderful. Thanks, Jake. Thanks for presenting with me. All right. Without further ado, let's jump right in. So a couple, I guess, disclaimers or informational sections I'll give. I'm going to be showing a lot of data in the first section of this presentation. We're going to be looking at ratings from 2020 that were done through Ekotrope. The data is just data, so I can't pretend to assume causation in all of this data. I'm going to pull out insights as we go, some interesting things that I see, and try to explain some data trends. But really, we're just looking at the data. It has not been manipulated. It has not been changed. So should be interesting stuff. There will be a lot of charts, a lot of visuals. If charts and stats and numbers are your thing, then should be fun. Buckle up. If they're not your thing, then, well, you can hold out until the second piece of this presentation, and Jake will talk about a few other things, including ACCA 310 and some HERS rating advanced modeling tips and tricks with Ekotrope. So let's start looking at some data here. So this section of the presentation is going to be using all HERS ratings that were done through Ekotrope in 2020. So that's about 200,000 homes that we're looking at. Pretty good chunk of data. And I'm going to go through and pull out different insights, but really with the goal of trying to understand homes that are on the low end of the HERS spectrum, so very efficient homes. What are the trends that sort of correlate to that? So how are builders getting to these very low HERS scores? That's what I'll be driving at from several different angles as we go through this presentation. But just to start, to get you sort of oriented with the data that we're looking at, what I have here is HERS index on the bottom of this chart. So to the left here, we've got lower HERS index scores. That means the homes are more efficient. And on the y-axis here, we've got how many homes have this HERS index. So this will be kind of a popular chart type that I'm going to use here in this presentation. The higher the bar, the more homes have that HERS index. But what we can see here is that there's a pretty even distribution. Most homes have scores between maybe 45 and 75 in terms of HERS index. And the most common HERS index in 2020 done through Ekotrope was a HERS 59. So that's kind of the median HERS score here. Also the mode, and that is, I guess, what you would say typical for a HERS rating across the country. Okay, now that we've sort of laid the baseline, let's start things off with a little quiz. So we don't have a live audience, unfortunately, but you can play along and try to answer the questions in your head. So a little competition, and I'll have Jake try to answer this question. What state would you say had the most of the lowest 1,000 HERS index scores that were done through Ekotrope in 2020?
Interesting. If I had to guess, I'm going to say the Ekotrope home state. I'm going to say Massachusetts.
Massachusetts. Okay, keeping it local. I like it.
Yeah.
Pretty good answer. So what we've got here on the top row are all the HERS ratings that are done through Ekotrope. It's kind of a heat map, so you can see it does cover most states. The left side here, you'll see darker regions where there are more HERS ratings. And you can see really it's most of the metro areas, a lot along the eastern seaboard, pretty well represented in Texas and places like that. The bottom row is showing where it's showing a heat map of the lowest 1,000 HERS index scores that were done in Ekotrope. So these are where the real low scores are residing. I'll say that these are the scores without photovoltaics, so without solar panel kind of pulling them down. And it's a trick question because I'm going to give it a split decision. It's really hard to call between Massachusetts and Minnesota. Both had a very high share of those lowest 1,000 HERS ratings. So some really great building being done in both of those areas, and potentially correlated to stringent energy codes as well as good utility efficiency programs that are helping to incentivize builders to build efficiently. Okay, great. So that's where they're being built. I'm going to continue to go through sort of a series of different slides and data here to try to pull these apart from different angles and look at different characteristics of these homes. So starting with something fairly simple here, just looking at the home geometry for homes that do not have solar panels. We've got, again, the HERS score on the x-axis here. So to the left, we've got more efficient homes, and to the right, we have less efficient homes. So I'm trying to understand if there's a trend in terms of, smaller homes have lower HERS index scores or larger homes do. And what we're seeing here is that it's actually pretty flat across most of this section. So homes above a HERS index of 45, you don't really see much of a trend. It's pretty flat. Maybe you see slightly smaller homes towards the high HERS index scores, but it's not much there. But what you do see here in this chart is that when we get towards these really low HERS index scores, 40 to 45, that floor area average tends to drop. So you'll see pretty significant signal here in terms of the really low HERS index scores. Those tend to be smaller homes as well. So we'll dig a little bit more into that in future slides, but something interesting to see there. Okay, next let's take a look at heating equipment. A very important aspect of the home's energy efficiency, especially in cold climates, is the heating equipment. So these charts are getting a little bit more complex, but let me sort of explain what's going on here. So on the top, we're looking at a distribution of the heating equipment type by HERS index. And then on the bottom, we're looking at heating equipment fuel type by HERS index. So the bigger the bar in each of these sections means a higher percentage of the homes in that HERS score bucket, like in that HERS score range, are going to be using that technology or that fuel type, right? So if we start here on the bottom, looking at this heating fuel type by HERS index, you'll see that up here in the high HERS score ranges, up 70 to 80 to 100, we've got a pretty big chunk of this dark blue bar, and that is electric. So you're seeing electric equipment on higher HERS index score homes. As the scores drive lower here to the left, we see a big chunk of this light blue. So as scores get lower into the 60, 50, 40 range, we're seeing the heating fuel type is dominantly natural gas by a very high percentage. And then as we start to really drop our HERS index scores, so down to HERS 20 here, HERS 0, even going into the negatives, these are homes that definitely have additional power generation, solar panels or something else. And what you start to see is increasingly, the heating fuel type becomes electric. So that makes sense because they're taking advantage of some of this extra power production to power the heating systems. Now, if we look a little bit deeper up here on the top and we break that fuel type into equipment as well, we see that, okay, this light blue matches up fairly well with the natural gas. So we're seeing that these natural gas homes are typically using furnaces, natural gas furnaces. That makes sense. And the electric section is generally air source heat pumps until we get into these really low HERS index score homes. And then you start to see this dark purple up at the top come into play, and those are ground source heat pumps. So even more energy efficient than air source heat pumps as we start to get into those very, very low HERS index scores. Okay, moving on, looking at both heating and cooling efficiency. So we've got heating on the left, just looking at AFUE for heating equipment. Cooling on the right, just looking at SEER for cooling equipment. And you'll see mostly the trends that you would expect, but with a little bit of subtleties. So looking at heating equipment first, as we drive scores downward, moving to the left on this chart, we do see the AFUE rise. So more efficient heating equipment, getting up all the way almost to 96 once we get HERS below 45 in terms of an average AFUE. There's a little blip here around HERS 55 to 60, where heating efficiency actually goes down. Pretty interesting to see that. I think it's actually a bit of a misleading trend in the data. I believe what's happening is that you've got a lot of homes that are in this HERS index range down in Arizona and Texas and climates that are generally fairly warm. So they are investing in cooling equipment rather than heating equipment. And so this is just kind of a chunk of southern homes where heating is not as important. It happened to fall in that range. Over on the right, we've got SEER by HERS index. So interesting thing here is that it's actually pretty flat across HERS index scores until you get down to about a 40. So you do see a very, very slight increase, but mostly around a HERS, a SEER 14, a little bit above a 14 average in terms of HERS index. And then it starts to drive up once you get to 40 and below. I suspect a lot of these homes here are actually mini splits or ground source heat pumps that carry both a high HSPF as well as a high SEER with them. Okay, let's break it up. Let's do another quick quiz here. So to the audience and to Jake, what would you say is the most common water heating fuel type among homes with the lowest HERS index scores?
That's going to be interesting, especially from that last side where you said a lot of homes in the low range move to electric, so they can have the solar, some split between natural gas and electric, but I'm going to say natural gas.
All right, natural gas for the lowest HERS index score homes. Let's take a look. All right, so similar chart here to what we were seeing for heating and cooling equipment. On the top is by fuel type breakdown, and then on the bottom is the actual energy efficiency of the equipment in terms of water heater EF, or energy factor. So if we look up at the top, we see a pretty interesting trend here. So the light blue is electric, the dark blue is natural gas. Everything else is just kind of lost in the margins up here. So not a whole lot of oil, propane, or wood. But what we'll see here is that up towards scores of 70, 80, you've got a lot of electric water equipment. And if we look down here at the EF, the energy factor of this equipment, you see we're down a little bit below 1. That signals to me that these are probably tanked water heaters around an EF of 0.85 or 0.9, and potentially also tankless water heaters around a 0.9 or 0.95 energy factor. But they're electric. And then as we start to drive down towards significantly lower scores, get towards HERS 60 into the 50 range, we really start to see natural gas, this dark blue, take a higher percentage of the market share for water heater fuel type. So natural gas really starts to take over here. So homes in the 40s and 50s are mostly using natural gas water heaters. It's a cost-effective way to drive the HERS score down. And then we start to see the trend reverse a little bit. So as we get into extremely low scores, 35, 30, even below, we see electric pick back up again. So dominant market share in that range actually becomes electric water heaters again. And what's happening, if we fill in a little bit more of the picture down here with this water heater efficiency graph at the bottom, you'll see that these EFs are launching upward above an EF of 1. And in order for a water heater to have an EF above 1, you're looking at a heat pump water heater. So what we're really seeing here is that heat pump water heaters start to become the dominant equipment type when we drive HERS scores down really to these deep low scores into the 30s and below. Okay, great. Let's look at insulation as well. So on the left, we've got ceiling insulation. On the right, we've got wall insulation. And we're looking at cavity and continuous. So cavity are these light blue bars, and the dark blue is continuous insulation. So as you'd expect, you see these start to drive upward in the low HERS index score ranges. And what you're seeing generally, especially significant if you look over on the wall section, as we get down to 50, 45, cavity insulation increases. You get a little bit of continuous insulation, but mostly cavity. And then to drive it even lower than that, yes, we see some cavity insulation increasing as well, but you really start to see a very significant portion of continuous wall insulation. So down to 35, 30, we're seeing this here is, R10 of continuous insulation on the wall. And this is probably about, R7 or so on average. So the picture that this paints is that cavity insulation is great, gets you down to a certain level, and then builders are starting to tack on that continuous insulation as well. Okay, so next up, sticking with the envelope here, let's take a look at windows. Do we see a trend in terms of what types of windows are being used on these homes? And I would say the majority of this chart is fairly flat. So at the top here, we've got window U factor. And yes, you see a very slight downward slope here. Lower HERS indexes have lower U factors, as you would expect, but it's pretty flat until you get to about a HERS, let's say 42 here. And then you start to see a drop off again, right? So once you get to that score of low 40s, you really need to get your savings from everywhere that you can get it. And builders start to invest in these super low U factor windows. Similar picture for SHGC, pretty flat around 0.25 for most of this chart. And then you actually start to see it increase once you get down below a HERS 48, 47. That is, generally going to be a trend in cold climates where you can actually increase your SHGC on these high performance windows and capture more of that solar gain to reduce your heating load in the home. Okay, a lot of pretty colors here. So what are we looking at? This is foundation type by HERS index. So each of the different colors are a different foundation type for the home. The pink here that's kind of dominating the picture is slab homes. So slab on grade construction. That tends to be overwhelmingly the majority of HERS ratings, probably because you've got homes, you've got a lot of homes being built in Texas, Arizona, areas where basements are not super popular. So that's the dominant, especially towards the higher HERS index range, continues to stay dominant down into the 50s. You do start to see some of this conditioned basement start to creep in, a little bit of unconditioned basement here down below. But the biggest trend that you'll see is once you start to get down below maybe a HERS 45, 50, get down into this really low range, you'll see these light blue bars picking up most of the market share. Those light blue bars are a foundation type of an apartment above conditioned space. So these are multifamily units. And this is telling us that as you get to these really extremely low HERS index scores, you're actually mostly looking at multifamily units that are sharing common walls, common surfaces with other units. Okay, let's do another quick quiz here. So we're going to be looking at mechanical ventilation next. Jake, would you expect homes with lower HERS index scores to tend to have higher or lower mechanical ventilation rates?
I expect them to. Well, we've been hearing a lot lately about how everybody's trying to build tighter homes, tighter homes. It makes you wonder, right? Does that mean ventilation too, or does it mean up the ventilation? I'm going to say that they're cranking the ventilation.
Higher
That's my guess.
ventilation for lower
Higher
scores?
ventilation.
Cool.
Yep.
Good thought. So let's take a look at the charts here and see what they tell us. So up top, we'll focus on this chart first. This is looking at the mechanical ventilation type. So what type of system is installed in the home? Now, we've got light blue here, which is representing air cyclers or CFIS systems. We've got pink, which is representing exhaust-only systems. Yellow is supply-only systems, and then purple over here is ERVs and HRVs. They get the same color. So what this generally is telling us is that if we start here over with high HERS index for homes, and we move to the left, we'll see that the dominant ventilation type with these high HERS index homes is air cyclers, continues to have very large market share as we go down the spectrum here, but exhaust only really starts to pick up as well. So you see a lot of exhaust only fans. As we start to get to HERS index score of, let's say, 50 here, air cyclers really pretty much drop off the map. You see a little blip over here, but not much in terms of air cycler usage on homes with HERS index scores lower than 50. What takes its place is ERVs and HRVs. So as you drive towards these very low scores, it becomes, and looking at super low scores over here, it becomes almost mandatory to have these ERVs and HRVs because you have to recapture that energy that's being lost through ventilation. So that's the type of ventilation. Now let's jump down here to the bottom chart and look at ventilation rate. Okay, so this is the actual amount of air that's being pushed through mechanical ventilation systems. We've got the light blue bars here representing the ventilation rate. And then I've also overlaid this dark blue line. This dark blue line represents ACH 50 or infiltration leakage of the home. Okay, so you see a pretty much reversed trend between the two. When ACH 50 goes up, mechanical ventilation goes down, and vice versa. That I guess is to be expected, right? Because as you have a leakier home, mechanical ventilation is, depending on who you talk to, a little bit less important, still important. But once you start to get these really, really tight homes down in this very low HERS index region, down below 40, what's happening is that these homes are being built extremely tight, very low ACH 50, and in order to make sure the air quality is high still, we need a lot of mechanical ventilation. And in order to not lose the energy that mechanical ventilation is pushing in and out of the home, we need those fans to be ERVs and HRVs. So you kind of get that whole picture. Once you get down into this very low score range, you've got super tight home, low ACH 50, you've got a lot of mechanical ventilation, and it's got to be ERV and HRV to recover that energy. Okay, let's jump over and look at lighting as well. Lighting can have a really big impact on the HERS score. And in a HERS rating, you basically have three options for rating lighting. You've got incandescents, CFLs, and LEDs. They're called different things in the ResNet standard, but that's usually what you're looking at. So over here on the right, we've got high HERS index scores homes. This white section is incandescent lighting, right? It's everything that's not CFL and LED or not tier 1 and tier 2. So you actually do see some incandescent lighting in these high HERS index homes. You also see a decent chunk of CFLs, around 20% here, but still a whole lot of LEDs, even in these really high HERS index homes, which is a bit surprising to me. You're still looking at maybe 70% LEDs on these homes on average. But as we start to drive these scores lower, down towards 50 and below, we see there's pretty much no white space at the top here. So basically 0 incandescent lighting. CFLs, this light blue, also drops near 0 and to 0 in some cases. So very little CFL lighting. We're looking at almost 100% LED lighting in these super low score homes. Okay, that was lighting. Let's also look at appliances. So washers and dryers also tend to have a pretty large impact on the HERS index. So similar chart here, and the different colors represent different options for washers and dryers in the HERS index, or in the HERS model, I should say. So yellow here, which is the dominant market share up above in the high HERS index scores, that's using the HERS reference washer and dryer presets. So if a home doesn't have washer dryer installed, or if they can't, the efficiency can't be verified on them, the rater is instructed to use HERS reference defaults, so the home doesn't get any credit for these washers and dryers. And that's what you're seeing up here in these higher HERS index homes. The big thing that we start to see is as the scores drive lower, we start to see this light blue take over the dominant percentage. And that light blue is custom settings for washers and dryers. That means raters are actually able to get these energy guide labels and actually take those measurements and put them into the HERS rating software. And it's telling us that, you really want to get credit for those washers and dryers in order to get down into the below 45 HERS index range. They also see a little bit of presets here in terms of Energy Star defaults and high efficiency defaults. That's probably something that we shouldn't see. I believe raters are supposed to choose either resonant defaults or custom and actually input it. So kind of interesting to see. It's a small amount, but interesting to see that there. All right, let's look in depth at leakage. We talked a little bit about ACH 50 before, but let's look a little bit deeper into it. So both of these charts are ACH 50 compared against HERS index, and you do see the trend that you would expect. You see lower ACH 50 here over on the left, tends to rise over on the right. So that makes total sense. Got a big cluster here, around 3 to 7 ACH 50 in this very common HERS index range. So there's a lot of dots here. It's hard to make a whole lot out of this chart. Interesting to me, though, is that you actually see a pretty large number of homes with ACH 50 above 5 in this range. And these are pretty good HERS index score homes, 60, even below 60. So with codes these days, usually at 3 or 5 in some climate zones, I'm surprised to see so many homes above ACH 50, above 5 ACH 50 rather. And this is the average on the right, just giving a little bit of a cleaner chart to be able to see what's going on here. So as we drive those scores down to 0 and below, ACH 50 really has to be below, 2.5 or 3 here. And then on the flip side of that, we've got duct leakage, also an important leakage metric. And you really see largely the same thing. Duct leakage is driven down towards 0 in the lower HERS index score homes. And you see that on the average chart here as well. So this is the sum of all the leakage to outside in these homes. So it's, looking at around average of 200 up in the really high scores, but then, down to maybe 0 to 50 in these low HERS index score ranges. All right, we're getting towards the end of this section. So let's do a final quiz here. So if we look at homes without PV panels, so without that supplementary electricity or power generation, what would you think, audience, and Jake, I'll have you answer this one as well. What would you say the lowest registered HERS index was in 2020 in Ekotrope without PV panels?
I remember at last year's conference at lunch, we were talking with some raters and we are kind of going around the table to see what they had seen. And if I recall, the lowest I heard at that conversation was a HERS 34. So I'm going to say 34. Let's see what happens.
34. That's a really good HERS score without PV. Extremely low number. Pretty good guess. So what this chart is showing us, we've got only two colors on this chart. We've got with PV and without PV. So the light blue here is the home has PV. The dark blue is the home does not have PV. So as we move to the left here, up above score of 50, pretty much no homes have photovoltaic panels, maybe, a very small sliver here at the bottom. You start to see a transition occur right around HERS 50, where there's a very steep slope. Homes start to incorporate PV. Below 40, the majority of homes have PV, and then that continues to increase sharply. We do see this, no PV hang on a little bit here. And when we get to the very last home that has the lowest score without PV, we're looking at a HERS 26. So very, very low score without PV. This is pretty impressive, lower than I would have expected for sure. And it actually is the same score as we saw in 2019 as the lowest score without PV. So I think we're kind of narrowing in that 26 is pretty much the best you can do without adding photovoltaics to your home. Below that, 100% of homes have PV panels. All right, and then I believe this is a final slide for the data presentation. If data isn't your thing, hold on tight a little bit, and we're almost through. So what we're looking at here is if we take the homes that have photovoltaics on them, and we look at what the HERS scores were, compared to the amount of solar on the home. So on the x-axis, we've got how big are the solar panels or how much power they generate. And then on the left, we've got what were the HERS index scores of these homes. So by plotting all this data, we can take a trend line to try to understand, okay, how does the size of the solar panel correlate to the HERS index? And it's really just it's a trend, right? It's not a one-to-one thing, because for a bigger home, you would need more solar generation to drive the score down. So it's not exactly a formula. But if you look at the trend, you'll see that on average across all homes of all these different types, if you add PV to the home, you're getting an average of about 3.2 points in terms of HERS reduction per kilowatt of PV. That's DC kW power rated of the solar system. So if you put on 2 kilowatts of solar panels on your roof, on average, looking at about 6.4 HERS point reduction across all different types of homes. So pretty interesting from kind of a research perspective there to see the impact of PV. All right, so we talked about how to get to low HERS index scores. I didn't mention anything about ACCA 310 because in 2020, ACCA 310 wasn't a possibility. In 2021, it will be a possibility, and a pretty exciting opportunity, I believe. So Jake is going to take over and talk about what 310 is, as well as, what's the opportunity? How does it have a chance to impact ratings?
Yeah, thanks, Cy. And next year, I'll sign you up early. I'm excited to see the same presentation again with some ACCA 310 HVAC grading information in there. So
Absolutely.
stay tuned. So yeah, I want to talk today about, what is HVAC grading, get a lot of questions about, what it's projected to be, how it'll tie into the HERS rating. And, also we want to touch on, is it worth it? So without further ado, let's just kind of jump on in. So HVAC grading, we've heard about it, we were talking about it, and basically it's a way of grading the installation of an HVAC system on a home. And it goes on a grading scale of 1 to 3, very similar to what we're used to in insulation grading within the walls. The only difference here is that HVAC grading is meant to be, I believe it's billed as the carrot without the stick approach, or in other words, there's only room for an increase in improvement. Or in other words, your HER score can only go down. It can't go up as a result of this, right? It's not meant to penalize people, but it is meant to provide benefits should you choose to do it. And it's a 5-step process, of which not all the steps are required. So you can, depending on how you score, do all 5, maybe do 4 of the 5, maybe even 3 of the 5. And the final thing I'll note here is that it does require additional training. Currently, Resnet has a 4-part video series as part of their modules. So you will have to go through that training, which is subject to change, but as it stands now, one more thing to complete. Moving on, let's just talk briefly about the grades that we have for ECHA 310. So again, 3 grades, just like wall installation. First grade, grade 1, denotes a high quality installation, right? Done a really great job setting it up. Everything's as it should be. This will give you the maximum possible score. The second grade, grade 2, is a mediocre run of the mill installation. You'll get probably some improved HERS score here. There's an opportunity for it, but you won't get the full effect of it. In many instances, in order to move on to the next step in this 5-step process, you'll actually need to get a grade 1 or 2. There are instances where grade 3 disqualifies you from proceeding further. And that brings me to the point of grade 3. It is the quote unquote default grade. It's equivalent to what you get if you don't do the HVAC grading at all. So again, won't penalize you, just removes the possibility for an improved score. And as I mentioned, it may prohibit further testing. So now let's talk about the different steps. Steps 1 and 2 actually should be familiar to many people. They're a design review and a total duct leakage test. And the reason I say that they're familiar for many people is because anybody who's doing an Energy Star rating or is going for an Energy Star rated home, they're required to do this test. So, this really won't require any change to your workflow, any change to your process. It's something you already should know. And these 2 things should be fairly easy to implement. Now, to get past steps 1 and 2, or in other words, to proceed on to step 3, you must actually score a grade 1 or 2 or better. Particularly on the duct leakage test, it's grade 1 or 2 or bust. On the design review, this is fairly pass fail. It's did you meet the tolerances or did you not? So again, steps 1 and 2, things that we're used to, nothing really new here. So let's move on to step 3. Step 3 is the first, one of the newer steps that people may not be used to, or could be a wrinkle in things for some people. It is a test of the blower fan airflow. And there are 4 ways you can do this, 4 methods that are approved. You can do a pressure matching, flow grid, flow hood, or OEM pressure tables. And to briefly walk through, for instance, maybe the pros and cons of each. Pressure matching, it contains tools that the rater already has, or very well may already have, so little cost to implement in terms of its new material or additional calibrations. But there are limitations. Mainly, this isn't a great method for larger systems. May not give you the best results. You can use a flow grid, which they're easy to use. They work at the high flow rate, so better for these larger systems. But there is an accuracy penalty. They're not as as accurate as some of the other methods, and they do require a little bit of additional setup. So it could be a little bit more time on top of everything. There's also flow hoods, which are fairly easy to use. You have a flow hood, you stick it on there, and you see what it says. Only downside here is, they're large, they're clunky, and if you're in a smaller area, you may not be able to fit it in. Also, they can be cost prohibitive, right? If this is not something you're already looking at or doing, this is another piece of equipment that you have to purchase. It's a little bit on the pricey side, something else to calibrate. So one more thing to think about. And then the final option is the pressure tables from the manufacturer, which, cheap, easy. You look at the table, doesn't meet, doesn't not, and it's the way to go. The only downside, I suppose, here is that you have to source this information yourself, right? So if you're not taking the information in the field, um, then you're going back to the office and doing the research, making sure you can verify that this is the exact equipment and getting the right spec sheets. So again, pros and cons to each of the four methods here. But the good news is it's a single measurement, right? It's not a series of measurements. It's kind of a one and done. And like many of the steps here, you must be at least grade 1 or 2 to proceed. So grade 3, you won't be able to proceed, but grade 1 or 2, you're good to go. So the next step, step 4, again, is a newer step. This is the blower fan watt draw. And what we're looking at here is, what wattage draw do you get from your blower fan? Fairly straightforward. They did a pretty good job of naming these, I will say. There's three methods you can use here to get this. First is a plug-in watt meter, or in other words, if the system isn't hardwired into the house, and you can actually plug it into something, you can plug it into a watt meter and read the wattage draw and record your values that way. Oftentimes, though, you might find that the system is hardwired into the home, so that's not an option to you. You can't actually get to the wiring. So you can use what's known as a clamp-on watt meter, which actually can measure the wattage by going around the wiring. They're great. They're fairly easy to use, but they do require some PPE and training requirements beyond that of the ResNet training. There's a level of safety there, and just again another level of training. So easy to use, but one more thing to consider. The final option that you have is actually just reading the utility meter. And what you do here is you actually just turn everything off in the home. You flip the breakers, and you only run the equipment for 90 seconds, and you read the meter, see what it draws from the meter. And that's great, simple to use. It's probably already in the home. But if there are other trades on site or other things being installed, you will have to flip all the breakers. That may require an additional level of coordination. So the other interesting thing about this is that you can proceed whether it's grade 1, 2, or 3. Now, you're only going to get credit for grades 1 or 2. Grade 3, you will not get any credit, but it won't prevent you from going on to step 5. So no matter what, you're good to go. Speaking of step 5, this is the one that when people call me and ask me, what's this HVAC grading thing? When are we going to be able to do it? What's it about? This is the one that they're always the most hesitant on. This step measures the refrigerant charge. And really, it's just an evaluation on how well that system was set up. And the biggest difference right off the bat is it's pass fail. So, with the exception of the design review, every test thus far has been grade 1, 2, or 3. Well, with this one, there's only grade 1. There's no grade 2, or you can have a grade 3. So, either going to do great or you're not going to do anything at all. That's just how it is. And now there are two ways to do this test. And it's worth noting right now, right off the bat, nobody's asking you to charge refrigerant systems, to kind of break into them, play around with them. We're not going to become refrigerant experts overnight and to get a whole new level of certifications. And I wanted to say that up front because I think one thing I always hear on the phone is, oh, they're asking us to tap into refrigerant lines. We're going to do certification. It's going to take a lot of time. Um, it's not really the case. In fact, the invasive method is actually just comparing air temps and refrigerant line temperatures, right? So we check the air that's coming out of the machine, going into the machine. We check the various refrigerant lines, see what temperatures they're running at. And we actually compare that to a spec sheet. So really, it is called the invasive method, but despite its name, you're not actually tapping into anything. You're really only just checking temperatures. The alternative to this is the weigh-in method. And this actually requires working with the contractor who installed it. You'll need to know various things about the type of lines they use. Some of that you can measure right then and there, or you might have to ask the contractor. But you will need to know the weight of refrigerant that was added, hence the name weigh-in test. And this is where that contractor coordination comes in handy. So if you are able to speak to the contractor and get this information, great. If not, then you might have to go to the invasive test method. Basically, once you have your weights and parameters, you then just go to a spec sheet to see what a system of this size and type should have and see, do I pass or do I not? Um, and that by that nature, that is why we have only a grade 1 or grade 3. It's a yes, no, do you meet it or do you not? It's very IO. Doesn't require any special certs other than it's the training that you get as part of being able to do an HVAC grading. Um, but it's a little bit safer than I think people are really worried that it will be. And again, it's all very much doable within the realm of a HERS rater. So, with that said, the second most common thing that we hear when people ask us about this is, hey, this is going to add hours to my rating process. It's going to take me a ton of time to do. I'm probably not going to do it just for that alone. And to that, I say fair, right? Anything that's new will require time, especially if you've never done it before. It's going to take more time up front, and hopefully, time will increase or decrease as you go on. You get better at it, it becomes a faster process. When ResNet was making the standard and when they were testing it for the first time, they actually recorded some of the times that it would take. And they found that on average, once they got used to it, uh, they were cranking out the entire test in about 26 minutes, so just shy of 30 minutes. Now, there was a caveat, which is that the equipment does need to run for a period of time prior to doing the testing. And the caveat here is that preconditioning, that pre-running, was done during the first two steps of the process, the design review and the total duct leakage. So again, a little bit of coordination there, kind of shift the numbers down a little bit. But as we look here, the average time for most of these tests, 10 minutes each, with the watt draw test being the shortest, 6 minutes. And they only did a handful of tests. If you do multiple of these throughout the years, you might be able to even get this lower. So I can't say that the modeling, the looking up, the paperwork aspect of it will only take 30 minutes. But the on-site time where you're actually doing testing, 30 minutes or less isn't terrible. I've been hearing people talk about 2 hours, 3 hours, and it may not be that bad. But to be said, it is additional time, so it does beg the question, is it worth it? So again, as part of the setup and implementation of this, ResNet, along with NREL, National Renewable Energy Laboratory, tested a set of homes. They tested homes with air conditioners, homes with heat pumps, and homes with furnaces. And so what we're looking at right here is homes with air conditioners. And in the lower climate zones, or the warmer ones, we see that with air conditioners, there's actually room for a few hertz points here, right? In climate zones 2 and 3, we see a change of 3 to 5 hertz points. So there is opportunity. If you need those extra scores, these lower points, it might be worth your while. In climate zones 4 and 5, however, the opportunity definitely diminished, right? So it may not be worth the time in that instance. Interestingly enough, if we kind of switch over to the heat pumps, we'll see that again, climate zones 2 and 3, huge opportunity. 6 points, 7 points, those are that's not anything to scoff at. That could really change a lot of these results. However, 4 and 5, we're actually also seeing potential here. 7 points in climate zone 4, 6 points in climate zone 5. That's a pretty good increase there. So if you see a home with a heat pump, regardless of where you are, there's a pretty good argument to be made that you should consider doing this testing. Now, the final one that they looked at was furnaces, and this was actually done down in Florida with FSEC and again in NREL. And so we'll see here that when they really dug down on furnaces, I don't have the exact numbers, but what they found is that again, the most points that you stood to gain were in those lower climate zones 1, 2, 3. They didn't really find that in climate zones 4 and 5 there's many opportunities there, which is a little counterintuitive despite what you might think, right? You have furnaces in areas with higher heating loads. But they did have some caveats and some reasons for that. Part of the reasoning was, small sample set. They did their best to get as many homes as they could, but perhaps not a large enough sample yet. The other thing that they mentioned was the software they were using was in a pre-release version that was specifically designed for this testing, but not yet ready for testing at large. So there might have been some assumptions made. There could still be some changes to the way the algorithms are created. I'm not sure which software that they used at the time. It's definitely it wasn't Ekotrope. We weren't asked to do this, but it is definitely a work in progress. And as this comes online, I anticipate that they'll be doing more tests, or in fact, they've probably done more testing since then, and we'll have more conclusive data. So that being said, you know, we see that there is room for improvement. We see that there's opportunity to drop the HERS score, but a question that we must ask ourselves is, okay, I can get 6 or 7 HERS points, but is that on every home, or is that really only like 1 or 3 homes? What's the deal? And the good news is that the majority of these homes that they tested on these newly installed systems, they they've gotten to the grade 1 or 2 category, right? So as you see here, the worst grading percentage that we got, refrigerant charge, only 20% of the refrigerant charge testing was grade 3. It was all grade 1. And for the tests that do have grade 1 or 2 opportunities, I mean, it's the majority of it passes, which means, you know, yes, there is room to get these better HERS scores. And if you do the testing, you'll find that the majority of your homes will actually meet them. It's not like, okay, I can get 7 points, but only 3% of those homes are going to get it. There's actually a pretty good opportunity here if we look at these numbers to to get your improved HERS scores. So again, wrapping it all up right now, HVAC grading, it's something that, maybe not as long of a process as we initially thought, maybe not as arduous of a process as we initially thought, and there's an opportunity here for many homes to really reap the benefits of it. So definitely something I'd encourage everybody to consider as it rolls out and becomes available.
So Jake, I'm gonna jump in here and ask a question and then answer a question that I'm sure a lot of our viewers will have, which is, when will I be able to use this? Right? It's not available in most software tools right now. And to that question, I'll say it is coming very soon. I promise you'll see it in the software tools. There is a ResNet deadline of April 1st, so you will have it available to you before April 1st of this year. And us at Ekotrope will try to keep everyone in the loop as best we can in terms of when these functionalities are going to be released, so that you can actually start capturing credit for these things.
Thank you, Sai, because aside from the what of the HVAC grading, the when was the second most requested question, and thanks for answering that for our viewers. Alrighty, so the last bit we're going to do here for a wrap up, a little bit of bonus material, is kind of cover some what we consider advanced modeling questions, questions that are beyond the very basic scope of how do I do a HERS rating, how do I import walls, input a slab, input mechanicals, things slightly beyond that. We'll cover some common questions, maybe throw a few tips in there, and point out some opportunities that we see, room for improvement. So the first one that we see a lot is actually errors in modeling duct leakage to outside. So for a while, there was the opportunity to take an exemption doing a leakage to outside test. And if you took this exemption, you could just claim that you had zero leakage to outside. And I believe that was prior to July 1st of 2019 on the permit date of the home, excuse me. So there might be a few stragglers still following that rule, but not the case anymore as we kind of move into 2021 here. Expect to see a lot newer permit dates. And beyond that, there's a rule that if you are not doing the LTO, if you meet certain requirements, then you take an exemption, excuse me. And if you're going to take this exemption, the way to not do it is enter zero, but rather there's this little box in Ekotrope that asks, have I taken the leakage to outside test? If you have, great, you check it. If not, you uncheck it. And there's a little handy flow chart here, basically breaks it down. So, right, did you do the test? Yes. Was there actually no leakage? Yes. Then you can enter zero. If you answer no to any of those, you can't enter zero there. So you got to uncheck that leakage to outside tested box. It's a common error that we see time and time again. And it's just something I just wanted to throw out there, maybe clear up any confusion. As a brief note, as it stands right now, actually, we're beyond this. So as it stood prior to January 1st of this year in 2021, it said that you If you had ducts in building cavities, then you could use this exemption. But for all new homes, we've moved into this period where if you have the ducts in building cavities or they're using building cavities, then you cannot take the exemption. So you have to do the test. So just another note to be aware of. Second question that we get asked a lot is, hey, I have my home and I'm looking at the mechanical equipment that's in it, and it has an ECM motor, right? An electronically commutated motor, which basically means that the fan speed can change. It's not set it and forget it. There's a little computer or something going on there that changes how fast the fan's spinning, and um, we have the ability to select between the two. So with an ECM motor, it's more efficient on the whole, but by itself, you won't see that change. So for instance, if you go from a PSC to an ECM, you might actually see that the home's performance decreases ever so slightly. And the reason behind that is the ECM itself, the change of the motor itself, isn't quite enough to be more efficient. In fact, according to ASHRAE 152, they actually have a higher duct loss, these ECM motors. So on their own, you might see a little bit negative savings. The real savings actually comes from the auxiliary electric, the EAE column here. And if you were to look at an equivalent system that has a single speed motor versus a variable speed, you'll often find that the EAE is lower for that variable speed motor. So that's really where a lot of your savings comes from. So people again will say, "Hey, I used a variable speed motor and my score decreased. I'm sorry, my score increased. It got worse." And I'll say, that might be true, but compare that same equipment to a single speed piece of equipment, and you'll see that the efficiency is much better, and on the whole, you will have a lower score.
So just to summarize there, Jake, it's important if changing motor type to also update that EAE field because that's what drives a lot of the efficiency in the model. Is that right?
That is correct. And if you leave that EAE field the same and change the motor type, you're probably not going to see the savings. But if you update that EAE accordingly and it's less than that of the single speed equivalent, then you will see savings.
Great.
Correct. So the next question we often get is, high scores in the mechanical ventilation, right? I get the question, hey, I added mechanical ventilation. Why is my home not doing well? What's going on here? I thought more ventilation is a good thing, especially what we saw earlier. Those lower HERS index score homes, they do have a lot of ventilation. So it's important to remember here what the winning combination is, right? Let's go back to size slides earlier. And he pointed out that yes, the homes with the lower HERS score have the highest amount of mechanical ventilation, but they are also built incredibly tight, or in other words, they have very low infiltration values, right? We were seeing ACH 50 values 1, maybe even less than, so that 0.5 to 1.5 range. That's really going to be where you get a lot of the benefit. If you have a home that's already fairly leaky or in that 3 to 5 range, and then you add mechanical ventilation, then really what you're doing is you're just creating more air that you have to condition, especially if you're just using an exhaust only option, right? Or a mechanical ventilation system that doesn't do any preconditioning for you. So that is one of the reasons why you might see worse scores even though you've added ventilation. Another thing to point out is, if you have to choose defaults for things such as, you can't measure the flow rate or you have to use the fan wattage default, then we're going to have to automatically calculate those values based off ANSI 301. And ANSI 301 2019 does have a table. It's table 4.2.2 that shows you how these values are calculated. And it might be worth your while if you're curious, just to kind of look at that table and compare to some of the systems that you have seen or have modeled and see, how does it match up? How does it compare? So just some things to consider when doing mechanical ventilation and possibly answering the question, how come it isn't performing as well as I thought it might? So the last one we'll talk about here, or one of the last ones we'll talk about here, is duct testing exemptions. And we get this a lot. People saying, "Hey, I'm taking a duct testing exemption. I don't want to do the test, It's just a 12% penalty, but it's only a 12% penalty. Why am I being dinged so harshly? And I think one of the biggest misconceptions that we have here is that saying that it's a 12% penalty is not the same as saying that you have 12% leakage. What this penalty applies to is something called the distribution system efficiency, or really is how efficient this distribution system on the whole is operating. And that's looking at more than just that leakage. So when you take this exemption, you are getting a distribution system that's only 88% effective, right? You're chopping off a large portion of that. And now let's say you're in a scenario where you're trying to eke out the last few bits of hurt points. Maybe you're up against code, you need to get there. Even though it takes longer, it might still be worth it to test your ducts, even if they're entirely in conditioned space. Very leaky ducts, I'm talking like really leaky ducts, 12, 15, 20%, it'll perform better than a system that has taken the duct testing exemption pathway. It's just it's a lot more restrictive than I think a lot of people are led to believe. And so again, my final parting word here would be, if you need the Hearst points, if it's possible, do the test. You will pretty much always come away better, even if everything's in conditioned space, by doing the test than you will by taking the duct testing exemptions. And so the final point that we'll get to here is, homes without air conditioners. So even if you don't model a home with an air conditioner, I got a surprise for you. You actually are. The resident standards state that if you have a home that has no air conditioner, then a 13 SEER piece of equipment will be added in both the reference home that you are compared to, as well as the rated home that you are modeling in the field. So, in other words, residents saying, hey, you don't have an air conditioner, for the sake of argument, we're going to assume that you do, and it is going to be a piece of an air conditioner as a SEER rating of 13. So, that being said, you're not really gaining anything there, right? It's kind of a wash. So it might be worthwhile to install a higher efficiency AC if Hearst points are a must. Maybe you get a smaller system in there that can just eke out a slightly better performance value, and you might see a positive impact in your Hearst score. You might be able to eke out that last little bit of a savings that you're trying to look for. So just a parting note that I'll leave you with again. Even if you don't have an air conditioner, there is going to be one in your model, regardless, behind the scenes, and it's going to be a 13 SEER system. So just something to be aware of, something that I don't think a lot of people realize, but comes up from time to time. So that really does it for all of the items that we had for today. Sai, any parting notes?
No, thanks so much for that information, Jake. Super informative. We don't have your name on this slide, but we should. If you do have any questions, unfortunately, we couldn't do it live this year for obvious reasons, but we'd love to hear from you. So feel free to direct questions my way. Email is here on the screen, cy@ekotrope.com. We'd be happy to chat, and I'm sure Jake would as well. But thanks everybody for tuning in. Thanks, Jake. Great session, and hopefully the viewers found it informative.
Thank you.